In this video, we'll talk about how to distribute and combine like terms. The distributive property states that multiplication distributes over addition. So that means we're going to have some real numbers such as A, B, and C. And if we use addition, we can see that A is going to be multiplied by the quantity of B plus C. That means A is multiplied by B to create AB, and then A is distributed to positive C. A times C would be positive AC, and that's where AB plus AC come from. Now we can go through these same steps using subtraction. A is going to be distributed to the quantity B minus C. So we would first multiply A times B, and that's where positive AB comes from, and then A is distributed to negative C. A times negative C makes minus AC. And this is how we're going to use the distributive property to help us simplify terms. Next, we're going to rewrite each expression using the distributive property. Example 1 has 4 times the quantity of 3 plus 8. Using the distributive property, that means 4 would be multiplied by 3, which would give us 12, and then 4 is distributed to the positive 8. 4 times positive 8 would be positive 32. Since 12 and 32 are both constant terms, we can combine those like terms to get an answer of 44. So we have completely simplified the original expression. In example 2, you're going to notice that we have a variable term x. So we will still be able to distribute 3 times x to make 3x, and then distribute 3 times our next term, which is negative 6. 3 times negative 6 is minus 18. What's different about this example is that 3x is still a variable term because it has a variable involved with it, 3 times x. And then the other term is 18. That's a constant term. So there's no way to simplify this anymore because we have two unlike terms. 3x is a variable term, while 18 is a constant term. So our final answer would be 3x minus 18. This time we're going to be distributing a negative 8x. Multiplying that by our first term x, you can see that there are 2 bases of x. So I could expand that with negative 8x times x, and then distribute negative 8x times positive 2. So the coefficients of negative 8 times 2 would give us a minus 16, and x is not multiplied by any other variable, so that would just be x. Now going back to this first expression, you can see that x was being multiplied by another x, so we typically would not leave it expanded. We would use exponent notation. So negative 8 is really multiplied by x raised to the power of 2, because we have 2 bases of x. And then we still have negative 16x. Now these two terms are not going to be combined because this first variable x is raised to a power of 2, and this variable of x is raised to a power of 1. So they're not like terms. This would be our final answer. In the last example here, this looks a little bit backwards from the way we normally see this. We've got a quantity and then multiplied by 4. So we could take our 6x and distribute that to the multiplication of 4. That gives us 24x. Then I'm distributing negative 3y times 4. That would be minus 12y. And last, distribute positive 5 times 4, and that would be positive 20. Now look carefully at each of these terms you generated. 24x minus 12y, x and y are not the same, so those cannot be simplified anymore. And the last term doesn't even have a variable. So this is our final answer, 24x minus 12y plus 20. Now you might be wondering if the sequence of operations will make any difference in what the final answer is going to be. So here's an example to answer that question. Working parentheses first, that means looking at 7 minus 4, I would have 2 multiplied by 3 because I worked the inner parentheses first. That leaves 2 times 3, which gives us 6. Now, if I distribute first, that means 2 times 7 is 14. Then distribute 2 times negative 4 would be minus 8. Since 14 and 8 are like terms, I can combine 14 minus 8, that is equal to 6. Notice how the final answer for each of these expressions is exactly the same. So if you prefer to work with the simplifying of parentheses first, that's fine. Or if you want to go directly to the distributive property, that's also fine. You will get the same answer. Now, when we're simplifying algebraic expressions, it's important to know a few vocabulary terms. So terms with the same variables raised to the same power are called like terms. We can add or subtract like terms by using the distributive property. This process is called combining like terms. So we have an expression here of negative 2a plus b. Notice that the plus sign is going to separate this expression into its individual terms. So one term is the negative 2a, that you can see is written right here, separated with a comma. The other term is positive b. So negative 2a is one term, b is another term. In our next example of 3x squared minus y over 4 plus 7, any plus or minus signs here are what separate our terms. So the first term is 3x squared, that matches. And the second term would be negative y divided by 4. Notice we're using the negative with that term, so minus y divided by 4. And last, the positive 7, and that would be our final term. So there's 3 different terms in this expression. Any plus or minus signs will be used to separate those terms. In our first example, we have 3xy minus 2xy plus 5 minus 7 plus xy. So just scanning the terms, I notice that 3xy minus 2xy and plus xy all have the same variables raised to the same power. So those are like terms. The coefficients involved are 3 minus 2 plus 1, all being multiplied by xy. And then I have 2 constant terms, positive 5 and negative 7. So those will also be combined. So the amount of xy we have would be 3 minus 2 makes 1. Add 1 more, that's 2xy. And then our positive 5 and negative 7 make negative 2. So our final answer is 2xy minus 2. In our next example, we have a quantity subtract another quantity. So this subtraction sign means we are going to distribute the negative to each term that comes after it in the parenthesis. There isn't a negative sign in front of the first quantity, so it's like having a positive 1 in front of it. When you multiply by 1, you're not going to have any changes in your product. So we're simply copying 2.1x minus 5.6. Now distributing negative times negative makes positive x, and then negative times negative 5.3 would be plus 5.3. Now that we have eliminated the parentheses, we can identify if there are any like terms. I have a variable term with x Here's another variable term with x. Since those are like terms, I'm combining the coefficients of 2.1 and positive 1. So remember, when you don't see a number in front of the variable, really there is a 1. So I'm adding 1. That common variable was x. And then I'm going to combine my constant terms. I have a negative 5.6 and a positive 5.3. All right, so now 2.1 added to 1 would make 3.1x. And I'm going to combine my constant terms. A negative 5.6 added to a positive 5.3 would leave me a negative 0.3. And this is our final simplification. 3.1x minus 0.3. In example number 3, we're starting with negative 4 distributed to the quantity of negative 3x plus 1 minus 3 times the quantity 2x minus 7. We'll start with distributing negative 4 to each term in the first quantity. So those two new products would be negative 4 times negative 3x makes a positive 12x. Negative 4 multiplied by positive 1 would make negative 4. So that clears that first parenthesis set. Next, we're going to distribute negative 3. So here we need to be careful because this minus sign is associated with the 3. So it is a negative 3 that we distribute. So negative 3 times positive 2x would be negative 6x. So we're subtracting 6x. And then negative 3 multiplied by negative 7 makes positive 21. We have 12x minus 4 minus 6x plus 21. So the next step would be to combine our like terms. I see I have two variable terms. Positive 12x minus 6x would become 6x. And finally, negative 4 would combine with positive 21. So I like to start with the positive number, 21, and then I'll be taking away 4. So 21 minus 4 means we're going to have positive 17. So you might be able to simplify, so you might be able to understand how to combine negative 4 and positive 21 better if you think about these numbers as money. You have $21. You're spending $4. So you will have $17 remaining. So it should be a positive 17. Our final answer is 6x plus 17. Our final answer is 6x plus 17.